right, today we're going to start off this lesson with you guys finding x and y using the mean proportional. This is what we did last week. Remember, there are two different mean proportionals when you have a right triangle with an altitude in it. One of them is the leg and one of them is the altitude. So you're going to start off and do that, and I'm going to check it when I check your homework in class. So once you've done that, you're going to come up with two answers. You should have gotten x is equal to 8 radical 3 and y is equal to 4 radical 3. But you've got to do the work to show that. Well, there's another way that that can be used to find x and y, and that's what we're going to look at today, and that's called the Pythagorean theorem. I'm pretty sure you're all aware what this formula is, but we're going to write it down together anyway. And it is the theorem that says a squared plus b squared is equal to c squared. Okay? We only use that when we have a right triangle, right? And there's something special about the c part of this. Remember, the a and b are arbitrary. They're the two legs of the right triangle. But c is the hypotenuse, and that's what you have to remember. Let's see if I can spell it. It's hypotenuse. All right, so when you look at right triangles, remember the hypotenuse is the side across from the 90-degree angle. So if we have our 90-degree angle here, the hypotenuse is going to be this side over here. So let me label that guy. This is C. It doesn't matter which one is A and B. Pardon my handwriting, it's not very good. I got to get used to this new pen I have. Sometimes it's difficult to see. So for the second triangle here, some of these sides look almost the same length, so we always look for the right angle, and it should be marked. This corner here would have the square in it. Once you find that, then you know that across from it is going to be the hypotenuse, so the side over here has to be C. So we'll label that C, and it doesn't matter which side you label A and B. So one of the biggest problems I've seen is students not identifying the hypotenuse correctly, or always just putting the variable on the side by itself. Don't do that. You have to find the hypotenuse, and that's the number, whether it's the number or the variable, that's what goes in on the side by itself. Alrighty, so we're going to derive the Pythagorean theorem, and what it means to derive something, it basically means you start off with just letters, and you're going to show the generic example. So we don't use numbers here. I'm just going to use letters to show how to come up with the Pythagorean theorem. So here we have our right triangle with the altitude. I'm going to go ahead and put the squares in where they should be. It's not very pretty, but there you go. There's a square, and there's my square to signify my two right angles, the right angle and the triangle, and then the altitude. And then I'm going to label the left-hand leg A, the right-hand leg B, and again, the hypotenuse is going to be C. And then the other two segments we're going to need are the segments of the hypotenuse, because we're going to do a mean proportional thing. It seems like you guys picked up on that pretty well. So this is x, and that's y. So let's find the mean proportional of side A. We're not going to do the one with the altitude, so I'm not labeling the altitude here. But I need that to get x and y. So remember, the leg of the right triangle is the mean proportional between the hypotenuse and its projection, and that's the side underneath the leg that you're talking about. And we're going to do this for A and for B. So here are my two proportion setups here. The leg is the mean proportional between the hypotenuse and the projection. When you cross multiply that, you get the fact that A squared is equal to C times x. We're going to do the same thing with B on the other side. The leg is the mean proportional between the hypotenuse and that projection. So we get B squared is equal to CY. Now I'm going to take their sum because I am trying to get to the Pythagorean theorem, and I know in the Pythagorean theorem we have A squared plus B squared. A squared plus B squared is going to be equal to, by substitution on the other side, A squared is equal to CX, B squared is equal to CY, so I'm just going to put CX plus CY here. This is what we do when we derive stuff. We kind of manipulate formulas to make them look like the way we want them to look. Okay, CX and CY. That's supposed to be a y. Again, my pen isn't so great. Then what I can do is I can factor this c out as a GCF. So I'm going to do that. I have a squared plus b squared is equal to c times the quantity x plus y. Now let's go back again and look at our diagram. Here we see that c makes up the entire hypotenuse, but when I break up the hypotenuse in parts, I have x and y. So if I want to represent c, that's the same as x plus y. So let me write that down. C is equal to x plus y. What I can do with that is I can replace this entire expression with just c. When I do that, I get c times c, and I'm left with a squared plus b squared is equal to c squared. There's my Pythagorean theorem. So what we did was use the whole similar triangle concept with the altitude dropped into the right triangle, and we've just derived the Pythagorean theorem. There's actually lots of ways to derive the Pythagorean theorem, but this is one using what we just previously learned in this unit. Okay, now we can go back to the opening exercise and find x and y using the Pythagorean theorem. If I look here, I have the two triangles. I've got the big triangle, which is this guy. This is x. This is 16. And then the other side, if I can look here, yeah, the other side is 8. So in this case, there's my right angle. You got to identify which one is C. If you look at the right angle, across from that is going to be the hypotenuse, so 16 has to go on the side by itself. All right, so we have x squared plus 8 squared is equal to 16 squared. X squared plus 64 is 256. So we end up with x squared is 192. Simplifying that radical, the largest perfect square in 192 is actually 64. So this is radical 64, radical 3, and there you have your 8 radical 3 when you're done. Okay, for the other triangle, we have, let me see if I can draw it over here. The little triangle that doesn't really look like a right angle, but just, yeah, do our best here. Y and 4 and 8. Again, this time the hypotenuse is 8 because it is across from the right angle. So when we put this in, we have y squared plus 4 squared is equal to 8 squared. Y squared plus 16 is 64. Here we want to find the square root of 48, which we know is 16 and 3. So in the end, when you simplify, this is going to be 4 radical 3, just like we found it before when we did the mean proportional. So you can use the mean proportional, or sometimes you can use the Pythagorean theorem when you're dealing with right triangles. Okay, so now we're going to work through a variety of examples for your notes, and then we'll be doing more of this in class. The first one says, find the missing side to the nearest tenth. If I don't get a whole number, we're going to round to the nearest tenth. So the first one here, we have 9 and 41, so I'm going to put my variable here because that's the missing side. And when you look, the right angle is right there. Across from it is going to be the hypotenuse. So that's the first thing I always identify, is that the 41 is going to be C. Once you have that, you just put it in the formula. X squared plus 9 squared is equal to 41 squared. X squared plus 81 is 1681. And this actually ends up being a perfect square, 1600. When you take the square root of 1600, you get x is equal to 40. When we have this, this is called a Pythagorean triple. And a Pythagorean triple is basically any set of 3 numbers when you put them in the Pythagorean theorem, or that work in the Pythagorean theorem, 3 whole numbers that work in the Pythagorean theorem. So let's write that down. Pythagorean triple is, here we go, 3 numbers that work in the Pythagorean theorem. Whole numbers. And the Pythagorean theorem. There you go. Examples of that would be 3, 4, and 5. If you put those numbers in the Pythagorean theorem, you always choose the largest number as C. That would work because it's 9 plus 16 does in fact equal to 25. Another one that you wouldn't think would work, but it does, is a 5, 12, 13. Those numbers also work. So that's another Pythagorean triple. And then as we've seen up here, the 40 and the 9 and the 41 is another Pythagorean triple. But, you know, it's not always the case that that's going to work. So if you look at the next example here, there's my x. Again, I have my c, so there's the hypotenuse. It's across from the right angle. So the 21's got to be on the side by himself. X squared plus 14 squared is equal to 21 squared. That's how you put that in the problem. And then when you finish up here, x squared plus 196 ends up being 441. You do not get a perfect square. You get 245. So if I were to take the square root of that and round, x is going to be approximately 15.7. Rounded to a tenth is 1 decimal place. All right, so that's some of the basic problems. We're going to do more complicated ones in class. So let's look at these word problems now. We have Tanya. Tanya runs diagonally across a rectangular field. That field has a length of 40 and a width of 30, and we want to know the length of the diagonal. So rectangle problems are common when you deal with Pythagorean theorem. Here's my rectangle. We know in a rectangle the corners are right angles, and there's the diagonal. Width of 30, length of 40. 40 and 30 are multiples of basically 3 and 4 multiplied by 10. So this is actually going to end up being a Pythagorean triple, but let's do the work. I'm trying to find the diagonal. That happens to be the hypotenuse, so that's going to be on the side by itself. And we have 40 squared plus 30 squared is equal to x squared. We have 1600 plus 900 is equal to x squared, so we end up with 2500, and x is going to be 50 yards. There you go. I don't have to put the yards because my problem already states in yards. And what I've told kids in the past is that you're better off not putting the units, because if you put the wrong units in, we have to take a point off. So you're better off just not putting any units in. So 50 yards, there's a Pythagorean triple. Okay, the next type of problem, something like this. The sides of a triangle are 7, 11, and 18. Is this a right triangle? Justify your answer. Well, when it says justify, that just means show your work. So make sure you show your work, and we're going to try this out in the Pythagorean theorem. To do that, you got to pick which one is the hypotenuse. The hypotenuse is always the longest side, so that's what you need to do. Let's just remember that. The hypotenuse is the longest side. So you choose the largest value. 18 has to be on the side by itself. We make our table here, or I'm going to show you how to do this. We're going to make our table, say a squared and b squared is 7 squared plus 11 squared, and I'm going to compare that to 18 squared. If they're the same, then it means it's a right triangle, and the Pythagorean theorem works. 49 plus 121, and 18 squared is 324. When you get done, you get 170 and 324. Nope, they do not match, so the answer is not a right triangle. And that's how you justify your answer, by showing your work. If those values were to work, like if you used the 40 plus the 30, and then the other side was 50, you would find it would work. You get a true statement, and then then it would be a right triangle. Okay, we're going to finish up with a few examples here, and then we'll be doing a lot of practice in class. So these are other types of examples you'll see with the Pythagorean theorem. Number 4 here, an isosceles triangle has legs that measure 10 and a base of 12. We want to find the length of the altitude. So I'm going to draw this isosceles triangle. Here we go, and the two side lengths are 10. I'm going to drop the altitude in here because that's what I want to find the length of, and the base is 12. Well, in an isosceles triangle, the altitude bisects the base. We've done that proof probably a few months ago. I'm sure you've forgotten, but if we drop an altitude in an isosceles triangle, everything is symmetric, so that's going to split the 12 in half, meaning that if I'm just going to look at one side is going to be 6. So my new right triangle that I'm looking at, this is x, this is 6, this is 10. Again, we look at the right angle, and opposite the right angle is the hypotenuse, so this is going to be c in the Pythagorean theorem. And the rest is going to look like this: x squared plus 6 squared is equal to 10 squared. I think we get a Pythagorean triple. X squared plus 36 is equal to 100, which means x squared is 64 and x is 8. That's the length of the altitude in that problem. All right, the second type of problem that you might see is dealing with a rhombus. The diagonals of a rhombus measure 6 and 8, and we want to find the lengths of the sides of the rhombus. So remember, a rhombus, all sides are the same lengths, and then there's some special things about the diagonals. I'm going to do my best rhombus here, kind of. Yeah, that's terrible, but we'll deal with it. In the rhombus, all sides are equal, but then there's also some properties with the diagonals. Remember, in a rhombus, the diagonals both bisect each other, and they are right angles. So what we have here in the middle are right triangles. If I can find the length of this side and this side, I can find the hypotenuse using the Pythagorean theorem, which is the side of the rhombus that I'm looking for. If the short diagonal is 6, then this little segment has got to be 3 because the diagonals bisect each other. So I'm going to make that little segment 3. Same thing with the other side. If the long segment is 8, it's bisected, so that side is 4. So here I have, and it's going to turn out to be a Pythagorean triple again. I have a right triangle with the two sides are 3 and 4, and I want to find the hypotenuse. So here's my side that I'm looking for. 3 squared plus 4 squared is equal to x squared. 9 plus 16 is x squared. This is a Pythagorean triple. It's a 3, 4, 5 right triangle, which means x is 5. So the side length of the rhombus is going to be 5. And remember, all sides are the same length. So if you find one, you found them all for the rhombus. Okay, the last example is a square. And this square has a diagonal that measures 12. It doesn't seem like we give you enough information, but we do. We want to find the sides of the square in simplest radical form. So let me see if I can draw a square. Or if my software, nope, that's triangle, never mind. That's what I get for trying to be fancy with this thing. Okay, here's a square. It's a pretty ugly square, but consider it a square. There, I made it a square. And here's the diagonal. This time we know the diagonal. That's 12. We know the angle in a square is 90 degrees. And we also know that once I have one side, I have them all. Okay? Well, I'm trying to erase, and it's not erasing. I don't know why. Okay, never mind. I won't erase. So basically, if this is x and this is x, we can still use Pythagorean theorem here. The hypotenuse this time is 12, and the other two sides are the same length. So if I write my formula this time, it's x squared plus x squared is equal to 12 squared. Now I need to combine like terms. When I add x squared and x squared, please do not tell me it's x to the 4th. No, no, no. It's 2x squared, please. 2x squared is equal to 144. I'm going to divide away both sides by 2, and then I'm left with what I'm normally left with. X squared is equal to 72, so x is equal to radical 72. Now we can simplify that. The largest perfect square that goes into 72 is 36. 36 and 2. So your final answer is 6 radical 2. There you go. So that's a little introduction to the Pythagorean theorem. We're going to be doing a lot more examples in class.